Okay. So coming to applications of differential equations to real-time problems, um, there have been some standard examples in literature in many books, like the Newton's law of cooling, law of natural growth or decay, usually which happens, growth happens with bacteria, decay happens with radioactive metals. Okay. So how does we formulate a real-time problem into a differential equation? Of course, with a single parameter t here we'll be talking. When we talk about real-time models, there'll be multiple parameters. This is just a basic example for applications of differential equations. Actually, it's not two, it is off. Anyways, now coming to the how the problem is formulated. Let xt be the amount of the substance present at time t, and let the substance be changing chemically. As I have said, if it is bacteria, it grows in a very short duration. It grows with a faster pace. Similarly, if there are some radioactive metals also, they decay. Actually, they disappear into the environment. They react with different other elements in the environment and they disappear. So to formulate the differential equation, we have to take some statements either from physics or chemistry. There is this law of conversion which says that the rate, what's the process? What does this law say about the rate of change in the substance is that the rate of change in the substance xt is directly proportional to the amount of substance available at that time. It's directly proportional. Means more amount is present, more amount gets chemically changed. Means what? Either multiplies or gets decayed. If less amount is there, less amount only will get multiplied or less amount only will get decayed. That's what exactly this law says. So how do you formulate it? Formulate the statement into a problem is, I have already we have already taken the terminology to be xt. So the rate of change, when I say, it involves a differential equation. Rate of change is nothing but change in x. X is a function in t, I mean with time na. So rate of change will be with respect to t only. So I'll be considering dxt by dt, or dx by dt is directly proportional to proportionality symbol. This is, all of you know, is equal to x of t, or x I can directly say, guys. Okay, now here comes my two different things. What that is if it is growth, there's a slight change. If there is a decay, there is a slight change. What that is obviously I can't handle this proportionality symbol. Na? If there is an equality symbol, I can handle it. So to remove that proportionality symbol, I'll be introducing a proportionality constant. Usually we denote that proportionality constant by k, as many of you know. If it is growth, this k will be positive. Okay, guys. If it is decay, the k will be negative. Okay. For the decay, the proportionality constant would be negative. For the growth, the proportionality constant will be positive, symbolizing that the substance is growing. Okay. No other, not something very big. Okay. Not something very this. Now, how do I solve this? I just go with variable separable. How do I solve this differential equation? Dx by xi will consider k into dt, whether it is k or minus k. Depending on that, I'll be considering k into dt. I integrate on both sides. That's what is, if I'm able to separate the variables, dx, x terms come for dx, and with t comes my dt comes my t terms, then I'll be calling it to be variable separable, as all of you know, which is a basic a differential equation model. Okay, first order differential equation model, which we start with separable. Okay, where you will be integrating and getting the solution. Since I'm integrating once, which is an indefinite integral, I'll be introducing an integrating constant. So I'll be having what here? Log x is equal to kt. If it would have been dk, I'll be putting a minus kt. Plus, I can as well write a constant to be c or log c according to my choice. There is no issue about it. Okay, if log c is taken here, it will be log x minus log c, which would be like log a minus log b, which would be log a by b. And then this would result in log x by c is equal to kt kind. Okay. Yeah. Now, if it would have been minus, then things would be different again. I mean, slight change will be there. If I have to remove log, I have to apply anti-logarithm. Okay. Which is nothing but on the right side, I'll be having x by c. On the left side, I'll be having x by c. On the right side, I'll be having anti-log, which is nothing but e power kt, or x is equal to c into e power kt. Now, according to different things that are being asked to me, I'll be finding different values for different times or different x values. If you are asked to find x, given t, I'll be finding x. If I am asked to find t given x, I'll be finding x, because I have one function or equation which is where x is expressed in terms of t. Okay. Now, anything I want anywhere, I'll be able to find out. This is how we will formulate a real-time problem into a differential equation. Yes.